Identifying the cause of mechanical failures in steel sucker rods and couplings can be very challenging. It's sometimes necessary to look past the obvious and seek clues from the not-so-obvious to determine the source of failures. Loss of displacement failures can cause breaks in both sucker rod pins and couplings. Basically, loss of displacement means the joint was not made up tight enough or the joint came unscrewed down whole. Typical loss of displacement failures on sucker rods will result in the pin breaking in the first full thread root above the stress relief. Pins will normally show a small fatigue area and a rather large tensile tear area. Other break configurations will vary depending on the loading conditions of the rod string. Couplings which fail due to loss of displacement typically show a 1/3 to 2/3 failure. The shorter portion of the coupling will be approximately 1/3 of the length of the coupling. Notice that on the brake face, the tensile tear is approximately 2/3 of the face, and the fatigue failure is the remaining 1/3. The ratchet marks will emanate from the thread root on the ID of the coupling. Ratchet marks on the OD indicate another type of failure. Fluid cut failures will show a path where fluid has rushed between the coupling face and the pin face. This indicates there was standoff, or a separation between the coupling and the rod because of loss of displacement. Over-torque failures on couplings will show very distinct characteristics. Look for a fatigue failure that completely encircles the face of the coupling, with ratchet marks doing the same. You will also note the ridge that encircles the face. These are the typical signs of over-torque on virtually every class or grade of couplings. Over-torque can also result in pulling the pin completely off the sucker rod on the softer grades of rods. High-speed power tongs can also twist the pins off the softer, lower-strength rods. Contaminated connections require more torque to make the joint than clean connections. Contamination may also cause the coupling and the pin threads to gall, and every galled connection will eventually fail prematurely. There's no substitute for clean connections. Power tongs make up better joints more consistently than hand wrenches. However, power tongs can also damage rods. One common area for damage is on the wrench squares where the backup tool fits. Always check the type of rods that are being run or pulled and make sure the proper dimension backup is in the power tongs before you start making or breaking joints. Otherwise, as you can see from the example, fatigue failure can result from this type of damage. High-speed fluid cut can be induced by having a large diameter pump plunger with large rods inside small diameter tubing. In this case, abnormally high fluid velocities cause the wrench square and the rod body to suffer severe erosion. Fluid pound is caused by incomplete pump filling. When there's a void in the pump barrel and the plunger is on the downstroke, the velocity of the plunger increases. When the plunger hits the fluid column in the pump, it stops until we have a load transfer. This causes the rods to bend in the tubing, and usually they'll strike the tubing wall. Tubing slap creates a multitude of problems. Compression of the rod string causes stress cracks that are close to the upset. These types of stress cracks usually do not extend all the way around the rod, but they always lead to rod failure. Tubing slap also causes couplings to fail. Couplings that incur stress cracks from this type of damage will nearly always fail in a 50-50 configuration. Brake faces created by compression from fluid pound have distinct characteristics. Note the ears extending beyond the brake face. This configuration indicates a double shear lip brake face. It is the result of unidirectional bending. A unidirectional bending failure means the rod string failed under a compressive load. Compressive loads will usually result in distinctive wear patterns on the couplings as well as the sucker rods. Look for longitudinal wear patterns that completely erode the walls of the couplings and the rods. Compressive loads also cause transverse stress cracking due to flexing when the rod buckles on the downstroke. Unanchored or improperly anchored tubing can also induce severe wear on steel sucker rods and couplings. Diagnosing rod or coupling breaks that may be attributable to unanchored or improperly anchored tubing is difficult and should usually be referred to your Norris representative. Wear patterns on couplings that result from deviation will be equal in their length, width, and depth. Rod rotators will extend the life of couplings experiencing wear as a result of deviated well bores. When coupling metal loss extends below and into the rod shoulder, it indicates the coupling should have been replaced earlier. The combination of tubing slap and wear can produce some very strange wear patterns. When couplings slap the tubing, they effectively become work-hardened at the point of contact. When this type of ridge is being produced as a result of tubing slap and wear, it is also creating a potential leak in the tubing wall. Overloaded rods show distinctive stress cracking. These stress cracks will be very fine, extend all the way around the rod, and over the entire length of the rod. This pattern will even include the wrench squares. Overloaded couplings will fail in a 50-50 fashion. The brake face will exhibit a small fatigue area, and the ratchet marks will initiate at the OD of the coupling. This is a common break for high-strength rods with 7/8" slim hole spray metal couplings. Corrosion failures present their own unique patterns. Suspected corrosion breaks should be sent to Norris for analysis. In examining corrosion breaks, it's necessary to examine the break exactly as it came out of the well bore. The sample should not be cleaned or treated in any way. Please ship the sample to us as is. Carbon dioxide, or CO2, produces a series of pits that are deep, round-based, steep-walled, with sharp edges. Sometimes the pits will take a different configuration depending on the type of sucker rod being used. Generally, soft rods tolerate corrosion attacks better than hard rods. A primary consideration in choosing a rod string is to get the softest rod that will handle the load. CO2 does not normally produce stress cracks in the bottom of the pit it causes. Loading produces the stress cracks. Carbonic acid is a combination of CO2 and just the right water conditions. Carbonic acid is extremely aggressive and can completely erode rods and couplings. Please consult Norris for recommendations regarding this type of corrosion. H2S, or hydrogen sulfide, can also produce extreme damage to sucker rod strings. H2S attack results in pits that are random over the rod, deep with steep walls and round bases, with beveled edges and a stress crack in the base of the pit. H2S can also cause embrittlement, which will exhibit a granular break face. The initiation point may or may not be visible, and a fatigue area may not be present. Bacteria will result in a completely different set of conditions. If the rods seem to have patterns of odd shapes or bright speckled areas, you need to consider that your rods may be under attack from bacteria. As a bacterial attack progresses, the localized area will become more pronounced and most will have stress cracks in the center or the bottom of the origin. Eventually, the bacteria will produce shallow pits with round bottoms, with tapered walls and beveled edges. They will also have stress cracks in the bottom of the pits. Bacteria pits are also unique in that they will often have a small trench around the edge of the pit. SRB, or sulfate-reducing bacteria, often colonize in groups. The pits are shallow, round-bottomed, with tapered walls, and they'll have stress cracks in the bottom of the pits. The pits will usually be a different color than the rod body. Chlorides, or salt water, will also damage sucker rods. Chloride pitting is typically small in size, shallow, steep-walled, sharp-edged, and random over the rod. Chlorides are more aggressive to carbon steel than to high alloy steels. Oxygen evaporates large amounts of material. Generally, couplings will be sacrificial to oxygen. An aggressive oxygen attack can rapidly erode couplings without harming the rods. Electrolysis, or stray currents, will produce two shapes of pits. Arcs originating on the rod will produce a round pit with a small cone at the base of the pit. If the arc initiates on the tubing, the pit will be deep and random in dimension. Electrolysis is extremely aggressive toward the rod upset since it is closer to the tubing. Manufacturer's defects are fairly easy to detect. It's very important that you understand these defects so that you can file accurate claims for reimbursement on defects. None of the failures presented in this video had a protrusion extending over the brake face as in this sample. All other aspects of the brake face are the same as those seen earlier, except for the protrusion over the brake face. This protrusion is a rolled-in mill lap. It occurred at the steel mill and is a manufacturer's defect. Scabs are large pieces of material that were also rolled in at the mill. Scabs appear as a very large segment protruding over the brake face. This is a straightener burn. As this raw bar was being straightened, it became stuck in the straightener and the bar was damaged. This type of break is not H2S embrittlement. It is incipient grain boundary melting. This condition is caused by forging the rod at too high a temperature for the steel. Unfortunately, no inspection exists that will catch this before it is shipped. Fortunately, these pins will usually break off during the makeup procedure. Norris has virtually eliminated the incidence of incipient grain boundary melting by using optical pyrometers on our forging equipment. Excessive die stamping can also produce failures in the wrench squares. This sample shows how the brake face emanates at the point of the die stamping. Polished rod failures are usually the result of severe over-torque on the polished rod clamp. As you will note, the brake face has exactly the same characteristics as a sucker rod brake. Understanding the effects of seemingly minor damage to sucker rods and couplings and knowing how that damage can produce catastrophic results is very important. Every step that can be taken to eliminate the premature failure of sucker rods must be taken.